What's up, guys? It's Mr. Knight coming to you not live today. This will be a pre-recorded video because today will be um, pretty much not a really big learning day. So I'm going to try to get a little tutorial video. It's a short one on what we're going to be hopefully covering today in class. It's our goal anyway. But anyway, the rest of class time we'll be doing a little teaching on what I'm talking about, what I'll show you in a minute on Lewis dot structures. And then also we'll do some we'll do atomic theory presentations, atomic theory timeline presentations today, and then maybe a few minutes here or there on some other little administrative tasks. Anyway, so you won't be missing a ton of new content besides what I'll show you in this video, and hopefully I'll be able to update you further with newer content. Once again, it's Monday, October 12th, 2020. Let's do some science. Let's do some chemistry. So go dogs. All right, so here's our first do now. Here's our do now for October 12th, 2020. Once again, this is the bonding lesson, the first day of bonding. We'll be doing some other things, like I said, that you won't, it's not new content, but it's atomic theory presentations, kind of taking care of business from that front, and some other administrative things. And if we begin the investigative task, I'll be sure to post those things as well. So look for that according to this video as well. But it's bonding 1.0, night science. We're doing some chemistry today. So let's take a look at what we got going on. All right, so you got your do now. Take a look. Prepare materials for a timeline project presentation. We're going to do some Lewis dot structure, a Lewis dot diagram for the following. That's magnesium, aluminum, nitrogen, phosphorus, oxygen, sulfur, and bromine. Remember, the hint is that it has to do with the electrons, of course, just as a memory. So I would say pause right now, try to do those on your own, and then I'll go over those in a moment. Okay, here we have magnesium. Second column, so it gets 2 dots because it's the number of valence electrons it has. Remember, Lewis dot diagrams or Lewis dot structures just represent valence electrons. The way I drew this was I drew the one on top first, and then I went to the right side next. Best systematic approach to drawing electrons via Lewis dot structure is to draw the dots around it as if there's a box around it, along the 4 sides of the box or square. One per side and going around clockwise. So putting dots in, since magnesium has 2, I put 1 in, and then I put the second one in, and that would be its 2. Aluminum and nitrogen, you can see aluminum is in group 3A, so it gets 3 dots, 3 valence electrons, 3 dots. Nitrogen is group 15, so it gets 5 or 5A, gets 5 dots. For nitrogen, once again, I go clockwise. Around it, I go the first one on top, and then around, bottom, side, and then the second one on top. That's just a good systematic approach, just like to draw your electrons the way you would in an orbital diagram. You start from, you go from S to P, you just go around the horn like that. Just kind of works out that way. Works out better. It's better when it's more careful of a way to do it. It's a more careful approach to do it. Now, does it matter which side those 2 dots are on? No, because later on what we'll see is that for bonding reasons, those 2 dots can move around to either side or can be placed anywhere. So the systematic approach works well for drawing Lewis dot structures for single atoms. But when we get to compounds, it's going to get a little bit more complex. Not much, but a little bit. You'll see soon. And all that means that you can put the 2 dots, called a lone pair of electrons, anywhere on its sides, and just swap those around, just as long as you have the main amount. Notice you can't have more than 2 per side of that letter. Remember, we're pretending there's a box around nitrogen, and that box around the N symbol can't have any more than 2 dots per side, which would lead to a total of 8. Now, there are some rules that can be broken on that and flexed on that. But this is just to illustrate some of the beginning points. Can you draw them first? Then we also have, let me make this a little bit bigger. Sorry, y'all. Let's go back. We got magnesium, aluminum, nitrogen, phosphorus. Notice phosphorus is in group 6A, so it gets 6 dots. I'm sorry, group 5A, same as nitrogen. Sorry, phosphorus, 5A. Oxygen is in group 6 A, or 16, so it gets 6 dots. And sulfur isn't the same as oxygen. It gets 6 dots. Bromine, 7A, it gets 7 dots. And of course, if we have a noble gas here, we put that 8th one there where bromine has a blank spot, which is a key point to indicate when we're talking about lowest dot structures. So there's your little key. If you saw this key ahead of time, make sure you go back and pause, and take a look at those again. All right, we're going to continue right along in the slides that we would be doing in class. So what's a valence electron? Remember, valence are the outermost electrons. They exist in the outermost shell. In this case, this would be a group, let's see, 3. This would be a group 3A atom. Specifically, we can tell if you look at it, has 6 neutrons in there, or 6 protons. Actually, it's not even neutral because it only has 5 electrons. So that's interesting. But those 3 outermost, highlighted in red for you. We can determine the number of valence electrons by looking at the A group names. Of course, you know that. You should know that at this point pretty heavily. If you don't, well, you do. You get it. All right, let's keep going. So you can see the valence electrons per group. In this, they're assigned this way. Why do we not do the D block? Because there's some more complexity to that. We'll get into it when we get into it. All right. So if we had some more practice, lithium, carbon, oxygen. If you need some more practice, go ahead and do those. And I'll flash that key up here in 1 second. But pause for a minute if you want those extra ones, and then you'll see the key the next page. All right, so there's lithium and carbon. Wrong way. There's oxygen and neon. Of course, we saw oxygen again. Notice neon is maxed out on those. Now, there are rule breakers to this, and there are some addendums to these rules, like for carbon. We can actually see sometimes carbon appear as having 2 electrons as a lone pair. That means just next to them. See oxygen's 2 electrons right here. Those are called lone pair. And the other side also, there's another lone pair. Carbon can also have them as a lone pair, but we'll look at those intricacies later on. For now, these are both correct, and the only ones we need to look at as we go along. That. Okay, so there's lowest dot structures as they appear. I'm not sure that the last slide even showed up, so some of those dots came out of order. Anyway, valence electrons for these are as follows. I misread the question originally in case that didn't show up in my video. Those dot structures represent those valence electrons like hydrogen. And then here are some other ones. I got to fill in a little bit at a time here because some of those dots are just formatted incorrectly. So you can see valence electrons and how they exist for each Lewis dot structure. Pause if you need some more time. I'm about to move on. So the whole bottom line is this magic number of 8. And our next thing is to stretch that into chemical bonding and how that magic number of 8 is fulfilled via chemical bonds. It's all achieving that state of a noble gas, level of stability of electrons, and that's generally just the point, is just to get that situation matching the 8 state. And bonding is one way to relieve that itch, if you will, for atoms to achieve it. Anyway, think about this question, pause a second, and see what you can do. By the way, these slides can be found in the bonding folder. And you can definitely peruse them at your own pace. They won't include some of the Lewis dot structure stuff because that's relative. That's carryover normally from atomic theory, so I've yet to update those. Still, take a look at them. And here's a little video to part with you about chemical bonds, and then we'll broach more of this going into our investigative topic, investigative activity coming soon. But I'm going to play this video first. So here we go. There we go. Oops, it paused because of me. I'm just going to let you enjoy that for a minute. Sorry again. Wait. So I'm going to we'll let you watch that video again. I had some technical difficulties, so I'm going to let that play, and then you're good to go. That'll be it. Maybe even ahead of where we get to on Monday in real life class.